Yeah, good morning, all the trainers and also um, participant is Jane in here. We still wait for PNG participant join to us. Maybe we wait for 5 minutes more.
Oke, Bu Ami. Thank you.
Okay. Participant is attending to this morning already. Attend is Jane, Hafiz Ahmad from PNG. Is it from PNG? And also Aldi Alfiansa. Welcome to our synchronous this morning.
Hi. Can you hear me?
Yes, I can hear you, Hafiz.
Yeah, I'm from Bangladesh.
Oh, Bangladesh. Okay, welcome to our synchronous second synchronous on lesson 2.
Hello everyone. I'm sorry for too late.
Yeah, okay.
Morning, Mr. Tsunami.
Yeah, morning. We still wait PNG's participant join to our session. Okay, trainers, Cynthia, Riris, and also Rismanto, and also Ulfa. Maybe we can start at 9:28 now. We already have 3 participants, Hafiz Ahmad from Bangladesh, Aldi Afiansa from Indonesia, and also Jane Pauline from Philippines. Okay, Hafiz, thank you for joining this synchronous, which is we meet at the first time, right?
Yes, this is
Yeah.
last time.
Yeah, is it okay? Our voice clear to hear?
Yeah, I can hear you clearly.
Okay. Okay, thank you. Maybe in Bangladesh, what time there? Morning?
Currently, I'm staying in United States. It's
Uh-huh.
now 9:30.
I see. Thank you for your information. Okay. This morning, we already on the lesson 2 session in synchronous first on lesson 2, which is understanding marine meteorology information for fisheries sector part 2. Our lecturer today, we have Mr. Iris, Miss Cynthia, and also Mr. Rismanto. While we wait other participants join, that's okay. We can start this time. I'll give the time to Cynthia maybe to open the session of lesson 2. Please, time is yours.
Okay, thank you, Miss Ami. Hello, everyone. Today's lesson is about the understanding marine meteorology information for fishery sectors. And today, the class or the synchronous will bring or wrap up with the Mr. Riris Adrianto and Rismanto Effendi, and also me. If you're able to open your camera, please let me know, because we want to see your face and your handsome and beautiful face, and we can interact more. As well as if you don't have the background, maybe Miss Ami can help to share with you. So I will not take a long time. This session will finish as the schedule about the 11 past 15. So I will not take a long time, and the session will start with the Pak Riris or Mr. Riris Adrianto. Pak Riris, time is yours.
Thank you very much, Cynthia and Bu Ami. Hello, fellow participants. How are you today? I hope. Okay, I see Mr. Aldi, Mr. Hafiz, and Miss Jane. So it's very happy to have you here, and also I'm very happy to be able to join this Otga session regarding the Fisherman Field School, especially delivering the information and knowledge sharing regarding the meteorological information that can be utilized for our fellow fishermen in their activities at sea. So can I directly share the screen, Cynthia?
Sure, Pak. You can share
Okay.
the
Wait a
PowerPoint.
minute. Where is my... Okay, can you see my screen?
Yes, sir.
Okay, thank you. So the title for this session for today is Understanding the Marine Meteorology Information for Fisheries Sectors. And as you already had a previous 3 days that you have some background information regarding this climate and weather information. And today we will focus on the understanding marine meteorology information that provided for fishery sectors. So this session would be divided into 3 sections or 3 parts. First, I would like to deliver this lecture, perhaps for 30 or 40 minutes maximum. And then for the second part would be the simulation or practice with tools that we already provided in PMKG regarding the meteorological information that can be utilized by various stakeholders, including fishermen. And then the second part would be handled by Mr. Rismanto and Ms. Cynthia. And then the last part, we will have Q&A and discussion because we would like also to hear from all of the participants all over the world to share information regarding how marine meteorology information in your country. And we will also, after we deliver the marine meteorology information that provided by PMKG Indonesia. So, firstly, I would like to introduce myself. I'm Riris Adrianto. I'm working for Center for Marine Meteorology for almost 5 years. Previously, I belonged to Remote Sensing Division of PMKG, and I will accompanied by Cynthia. She is also a forecaster, marine forecaster in our center, and Mr. Rismanto is a senior forecaster for marine meteorology. You can contact me with the following email address: riris.adrianto@pmkg.co.id. Okay, so firstly, I would like to bring your attention to the importance of meteorological information, which is we provided for many stakeholders. So mainly we provide information for activities in the sea is aimed to safety at the sea. And then, of course, the ultimate goal of weather information that provided by all of meteorological services all over the world, including Indonesia, is to ensure that the sea activities, include sea transportation, would be safely conducted by all stakeholders, related stakeholders. So it is very crucial to the provision of marine meteorology information. And then the meteorological information is also crucial for route planning for many stakeholders. So in terms of fishing activities, the meteorological information that provided, such as wind condition and then current condition of the sea, and then wave height information. It's very important to be considered when the fishermen would like to plan their activities at sea. So by taking consideration of the marine weather forecast, they can plan the optimum route for their fishing activities. So it can enhance the efficiency or effectiveness of their fishing activities at sea. So they can choose the area that the weather condition is good, relatively friendly for their boats, and avoiding the area that can potentially danger their boats in some areas. So it is very, very crucial to pay attention for all stakeholders, include fishermen, before they plan to have activities at sea. And then also it relates to vessel efficiency, because by making a good planning for fishing routes, so they can benefit with the very efficient route for fishing, and then they can save fuel and other logistical matters during fishing activities. And then in turn, it can promote the sustainability of fisheries, because the weather factors or meteorological factors is very, very important factors for the sustainability of fisheries. And then it also needed for conservation of marine resource. And then regarding the hazard, the marine meteorology information can be utilized in the risk mitigation. So as we already aware that in many parts of the world, we often heard about the impact of bad weather in the ocean. So this is some news that we capture from various international media, that maybe almost every day it has happened, the accident or incident that occurred in the sea due to the bad weather. And of course, this promote the WMO promote the meteorological services for the sea. So in the WMO, we have a program named Marine Meteorology Program that especially provide information for marine activities, mainly to avoid those and to reduce the impact of bad weather to the sea activities, like that often happen in some areas in the world, the accident in the sea. For Indonesian experience, most of the sea accident or sea incident occurred are for the small boats, because sometimes and it is not only sometimes, often the small boats or the fishermen is not have they are not have sufficient information and knowledge and access to the information before they fishing to the sea. So since perhaps 5 years ago, we start to make a program that aim to improve the awareness of fishermen, especially, and also the sea transportation stakeholders to understand the importance of the marine meteorology information that provided by Indonesian Met services. So with those activities, we expect that the rate of accident at sea can be reduced in Indonesia, especially. So, and during 5 years, we have a very, very positive feedback from the users and stakeholders regarding our program. And then we are very, this is very good for us to improve, to motivate us to improve the content of this program in the future. So this is some of the alumni of our program that we conducted for fishermen in all parts of Indonesia. We have at least during 5 years more than 15,000 fishermen already participated in our program, and those two in this slide deliver their expectation after they became the participant of our fisherman weather field school. They become aware about the importance of PMKG information provided to them. So not only for fishing activities, but also aquaculture activities we would like to support in the future. So the fishermen and the aquaculture expect that in the future they can access information on marine meteorology more easier and more understandable by them. And this is really motivate PMKG to continuously improve the products of marine meteorology information to match with their needs, because we have to serve various sectors, so we have to diversify the product, especially for marine meteorology. This is part of our center duties. Yeah, as I mentioned previously, that how to increase the awareness of our fellow fishermen in Indonesia. We conducting the ocean literacy program for fishermen. We call it the Fisherman Weather Field School. So in Indonesia, we call it Slcn. It means the Sekolah Lapang Cuaca Nelayan. This is a Fisherman Weather Field School. So in these activities, 1 or 2 days activities with the fishermen, we introduce the product they provided for their activities. And then we also teach them how to access the weather information that already provided in the website or by mobile applications. And then by delivering this knowledge, we expect that the fishermen can also provide feedback to us when they doing fishing in the sea, so they can also observe the actual weather condition and then report to us, and the data that they deliver as a feedback to BMKG, it can be used for verification of our forecast, weather forecast. So with that, we expect that we can improve accuracy and the content of our weather information for them. So this mutual collaboration between PMKG and the users, especially the fishermen, are already initiated in some areas, and we got very good response, and they are very eager to share their visual observation, mainly because in their boat there are no sensors available there. So we just ask the fishermen to observe by their visual observation, such as wave height. They can estimate how high is the wave that they passing through during their fishing activities, and then they report by SMS or by WhatsApp when they are reach the coastal area, that they can connect to the cell phone network. And then so the final purpose is to improve the awareness of marine weather information to improve their wealth. So the production of fishing can be improved by utilizing the meteorological information provided, and then they can obtain fishing efficiency in terms of fuel usage by making a better route plan for their fishing activities, etc. So sorry, this is the basic information as for the marine meteorology services they provided by BMKG. It's starting from our observation. We have marine meteorology observation all over Indonesia, although it is not so homogeneous distribution yet, but we still making efforts to disperse more of the marine meteorology observation throughout Indonesia. You can see in the west part of Indonesia, it's relatively more observation comparing to eastern part. So this is still our homework, BMKG homework, to improve the observation system in the Indonesian region, especially middle and eastern part of Indonesia. So from the observation, it will ingest it to our data management system, and we have also the modeling system that we operate since 1990s, the end of 1990s. It is started to develop the modeling for marine modeling, and then it is improved year by year, and then now we the status for today, we have what we call it BMKG OFS, or stands for BMKG Ocean Forecast System, that comprised of 3 parts of the modeling. First model is INAWIF, that has 3 important output for prediction. INAWIF can predict the wave, and then the wind direction and wind speed, and also give information on swell prediction. And then second part, we have INAFlows. This model can produce the oceanographical parameters forecast, such as current, and then salinity, and sea temperature. And then this parameter we can obtain based on depth. So in several depth, we can obtain the parameter of current, salinity, and sea temperature that provided by our model in our flows. And then the newest one, we currently develop the coastal model. It's collaboration between BMKG and several parties, include WMO, and then Ministry of Public Works, and other governmental institution that collaborate to develop the coastal flood model, because our region, some of our region is prone to coastal flooding. So it is very crucial to provide the information on coastal flood warning for the public, because the coastal flood has significant impacts to coastal communities. Often the road is drowned by seawater because of the coastal flood during the high tides, and then it can be worsened by the increase of rainfall. So it is very, very crucial to have a coastal flood warning system. So we call it the model for coastal flooding is CIFS, Coastal Inundation Forecast System. And then all of the product that produced by all three models that we operate is provided through our website, and then it can also accessed through our mobile application, and then the product is delivered to all stakeholder related, from the Ministry of Transportation, Sea Transportation, port authorities, and then to the fishery and marine affairs ministers, and then to military and police that has office in the coastal region. So the products that we deliver routinely, such as the bulletin for shipping, and then forecast for route forecast for sea transportation, and then port weather forecast, and then prediction on wave height in daily basis and weekly basis, and then weather forecast for ferry crossing route, and then warning that we deliver when we suspect the adverse weather phenomena can be potentially occurred in Indonesian area. So all of the product can be accessed through the website provided by BMKG in the address maritime.bmkg.go.id. And some of the product can also access through mobile application. So this is the main page of our marine meteorology product. https maritime.bmkg.go.id. So here you can see the area that have a different color here. The area is represented the area of marine information that handled by all of our marine meteorology station in regional office. So each of these polygon representing the sea region or ocean region that belongs to a certain BMKG regional office that has duties to provide information for all stakeholders in their respective area of responsibility. So the in this website we can obtain the forecast of Indonesian waters for at least 10 days ahead. So what is inside of the website, we can have opportunity to learn together in the simulation lecture in the second part of this lecture by Mr. Rismanto and Ms. Cynthia. So this is additional information that the BMKG Ocean Forecast System is an information-based system for analyzing and predicting the oceanographic and marine meteorological parameter. It comprises of two main model, in-wave and in-flows, and then the address for accessing this product. All of the product are provided in this address. So later on, you will explore more about the product through the website. I would like to excuse for a minute because my power is already running low. Okay. Sorry. Yeah. So next we will understand about the marine weather parameters that represented in our marine meteorology information. So this is very important for non-meteorologist user to give the definition or explanation about certain marine meteorology information that provided by us. So first, what is wind speed and direction? So the simple definition to that we deliver to our user, our general public. Wind speed and direction is how fast the wind is blowing and where the wind comes from. So if we see the meteorological product on wind speed and direction, for example, the wind speed is 5 knot per hour, 5 knot or 5 kilometers per hour. Sometimes the dimension is different between countries. For Indonesia, we usually use knot, and sometimes we also use kilometer per hour. And then the wind information said that the wind is southwest. What is the meaning of the direction of southwest? Southwest, it means that the wind comes from the direction of southwest. From, yeah, comes from, not towards, yeah. If wind direction, it is an international agreement that the wind is measured from which the wind comes, from which direction the wind from. And then the next second parameter, important parameter, is what is the significant wave height definition, because this will be done in the simulation. So we have to understand first what is the product of BMKG of significant wave height. Significant wave height is the average measurement of the largest 33% of wave. So it means that from all of the wave that measured, so the 33% average, there are just 33%, it is averages, and then it is what we call significant wave height parameter. Okay, and then the next definition, what is sea current? Sea current is the movement of seawater masses that move from one place to another. Sometimes it is represented by centimeters per second or meter per second. Then what is salinity? Salinity is the dissolved salt content of a body of water. So how high is the salt concentration in the sea? It is the salinity definition. And then another product is swell. What is swell? Swell is a series of ocean surface waves that were not generated by the local wind. So it's generated by atmospheric and oceanographic phenomena in the distance, far away from the phenomena that occur. For example, for Indonesian region, the south part of Indonesia sometimes experience swell that generated by low pressure that occurred in Western Australia that affect the Indian Ocean to generate the swell. So it is not locally generated swell. It's different with the wind waves. For wind that generated by local winds, we call it wind waves. It is generated locally in the waters region. But swell is the ocean surface waves that generated not locally but by other factors that has a great distance from the phenomena occur. And then the next parameter is SST. What is SST? SST is sea surface temperature, the water temperature in the surface layer of seawater. So this is at least 6 parameters that should be understand first before the user go to our website products, our product in our website. So this is for the example of the product that we provided for wind speed and direction. This forecast for how many days? This is perhaps this is for 3 days, I think. So this product can be understand that the maximum reading of wind direction interval is 45 degrees, and the reading is clockwise, and the direction of the wind is from where the wind is blowing. From where the wind is blowing is the direction of the wind. If we represent in the arrow sign, you can see that the direction is showed by the red circle here. So it if the wind direction is stated southwest, so the arrow direction is like this. So the southwest is represented where the wind is blowing from in the red circle. This is for wind speed and direction product or forecast product. And then the second product is significant with height prediction. Here some explanation that the maximum reading of wave direction interval is also 45 degrees. And then it is a clockwise reading, and the direction of wave is also the same with wind, and that the direction of wave is where the wave is moving from. So the origin of the wave movement is the direction of the significant wave height. It's same with the wind parameter. The next product is sea current prediction. The maximum reading of the current direction interval is also 45 degrees, and the reading is clockwise, and it is a little bit different or opposite definition with the wind and wave, that the direction of current is the direction where the current is towards. So the direction where the current is moving is the direction of current. So the information of sea current, you have to be careful to interpret the definition of the direction of the current, because it is different definition with the wind and the wave. If current is toward, where is the current move to? But for wind and wave is from where the wind or wave is moving. It is the difference between sea current information interpretation and sea wave and wind interpretation. The next is salinity prediction information. We also provide in our website. It is mainly used for aquaculture activities, but it is still a relatively low resolution. We hope that in the future we can have more higher resolution for salinity profile to support the aquaculture activities in our region. So the salinity map shows that the more yellow to red is the higher concentration of salinity in the area, in the seawater, in the sea. And the color from blue to dark blue, light blue to dark blue is representing the lower concentration of salinity in the sea. Next, this is I cannot see the oh, sorry. So this is the animation of some product that we also provided. For example, for swell phenomena that can be observed in southern part of Java Island in Indonesia. You can see that the high wave that occur there is generated by atmospheric and oceanographic factor that occur in the south of Indonesia near to Australia, and generated the high wave here. And then this is the SST prediction in the right hand picture. Animation so it is 3-hourly animation. So you can check it in the second session in the simulation part by Cynthia and Pak Rismanto next after this. Here is the latest information system that we provided for specific stakeholders, like sea transportation stakeholder, port authorities, ship companies, that we call it INA-WIS, or Indonesian Weather Information for Shipping. So this is this system is dedicated for shipping activities. So this interactive web page can be accessed by the user, and the user can interact with the system to make a route plan for their sea activities. So we provide marine data monitoring also in this interactive system, marine weather forecast, and also we provide the weather impact information for shipping. So what is inside that, Pak Rismanto and Cynthia will explain later on in simulation part. And then the user can also make a route forecast for their ship. If they would like to depart from certain port towards a certain port, direct to destination, they can define the route of their ship, and then they can obtain the route weather forecast along the ship course of their routes. So it is very, very, very interactive and very interesting. You can check it out in the second part. So this is some of the tools or features that we have in Inavis. We already integrated several data and information in this interactive website. Ocean forecast, observation data, and then satellite images, include also radar, Indonesian radar, weather radar images also already incorporated here. So it is very, very useful for sea stakeholder, include the fishermen also. So during our field school that we already implemented in throughout Indonesia, we introduced also this interactive system to be able to be utilized by our user and stakeholder in the field in order to improve the safety at sea that they have in daily activities. So this is the explanation of risk level that you will find in the Inavis product. So we divided the risk based on the vessel types. So the smaller the boat or ship, the higher the risk would be faced from the marine meteorology factors. So this table shows the level of risk for wind and wave height. The color represent the level of the risk that have occurred in the sea region for specific vessel types. So if the wind speed is around 7 less than 7 knots, and the wave height is less than 0.5, it is still relatively low risk, very low risk for fishing boat. But if the wind speed is between 7 to 10 knots, and the wave height in the certain area is range between 0.5 to 1 meters. So for the fishing boat, it is categorized as low risk. For moderate risk for fishing boat, the wind speed is around 10 to 15 knots. And then the wave height is varies between 1.0 to 1.25 meters. It is moderate risk for fishing boat. And then what is the high risk that categorized for fishing boat? If the wind is more than 15 knots and the wave height is more than 1.25 meters. And then for barge vessel types, it of course it is relatively bigger than fishing boat, so the level of risk it is a little bit bigger than fishing boat. And then ferry vessel types, it is of course bigger size than fishing boat and barge, so the parameter of wind and wave height is bigger than the threshold for barge vessel and fishing boat. So you can understand the level of risk for each type of vessel by refer to this table. And then what is the dissemination method that we have? We use all possible dissemination means to disseminate as wide as possible our information to reach the user in the field. Even though some of the direct user in the coastal communities, sometimes when the mobile communication link is not so good there, our local communities user input fishermen sometimes report to us that they are having difficulties in accessing the information from BMKG. So the one of the solution that we provide is through the weather display that we place in the some of the fishermen village, in the port, or in the place where the fishermen, local fishermen usually gather. So we put port display for information, marine weather information there, so they can see through the screen the forecast that we deliver every day before they make fishing activities in daily basis. They can check every day because this display is real-time updated by our administrative IT administration person. So through social media also, and through email for the specific stakeholders like offshore oil company, to the government institution, local governments, and all of the stakeholders that still use email as a main communication link. But for public purposes, public users, we mainly use social media and weather display. And also we encourage the people to download the BMKG mobile application. We call it Info BMKG, to access some of the important products that we deliver, ranging from meteorology, climatology, and geophysical information are there in the mobile application that operated by BMKG. Okay, so I think that is all for my introductory lecture, and we will continue in the second part. I would like to handle over the session to Cynthia and Pak Rismanto for quiz and also simulation. Thank you very much for the attention to this lecture, and we will have a Q&A and discussion in the third part after the simulation by Cynthia and Parismat. Thank you so much.
Okay, thank you, Pak Riris, for your presentation. And for the simulation, it will take over to Pak Rismanto Effendi. Please, the floor is yours, Pak Rismanto.
Okay, thank you, Pak Riris, Cynthia. Good morning, dear all participants of OVGA training course of the Fisherman Field School. I am Rismanto. You can call me Riz, Center for Marine Meteorology. Nice to meet you all. So, as mentioned by Pak Riris in the beginning, that about PMK-GOFS and also INAWIS, or Indonesian Weather Information for Shipping. Both of them are the main part of our system to make a prediction for marine. So let me share my screen. Can you see my screen? Yeah, okay. Okay, perfect. Yeah. So we have the MKG OFS. So you just type like the MKG OFS and then click this one. Yeah, this is our web-based application and our product to make a prediction. So we have two types of models here. INAWaves, you can see in this one, INAWaves and INAFlow. So the INAWaves based on the global model called WaveWatch 3 with 10 days forecast and 3 hours time step. And also we have spatial resolution about 7 kilometers. And the second one is INAFlows. This model based on the FECO model to make a ocean prediction. So we have many parameters of the first one's INAWaves. So we have wind direction, wind speed and direction, significant wave height, wave mean period, primary swell, until wind speed. We have also in the initial time, this one is for the latest base run, and we also have the base run before the latest, because we have to run the model twice a day. So we run 0 Zulu, 0 UTC, and also 12 UTC. So for the area, we have Indonesia area, and then Asia Australia for the bigger picture. You can see the differences between them. Okay, this one for the wind speed. So we can predict from now until the 10 days. And also we have...
Hello, Mr. Riris, your voice is suddenly gone.
Hello?
I still can hear Pak Rismanto, but
Is it everyone can hear Mr. Rismanto's
yes, I
voice?
can. Yes, I can.
Oh, okay. So it's my...
Okay, this one for the wind speed. So we have significant wave height. We have direction and also the wave height in the meters. And also we have wave period, swell, and also wind speed. And the second model, we have INAFlows. This is the ocean model. It's only 3 days forecast with 3 hours time step. We have parameter like Slcn from the surface until 250 meters depth. We have Slcn, sea temperature from surface and also 250 meters, and also salinity. So this is the ocean forecast system, our first main model. And also we have INAWIS, Indonesian Weather Information for Shipping. You can just type INAWIS PMKG and click this one. Okay. We have to wait for the map. Okay, it's perfect. So in the left side, we have the parameters like wind speed, but the difference is between this one and BMKGFS is this is a dynamic map, but this one is a static map. So we can see the flows from the wind direction like this. This is one direction, and the color is the wind speed in knot. We can see in this one. And also in the bottom, we can set the time for the time what you want for the prediction. It's a 10 days forecast. The second one is a significant wave height and also Slcn and wave mean period. Yeah, this is how those are our parameters in the INAWIS. So in here we have also the weather impact for the types of ships. Okay, let's say we have cargo. The risk level of the ships. For example, if we click on this one, on the fishing boat, so we can see the color like yellow, orange, and red. We have this one, risk level is yellow is low, orange is moderate, and red is high. So this is based on the wave height and also wind speed. For example, in this one, in this area in Java Sea, for the fishing boat, the risk level of the fishing boat is low. But if we go to the Pacific Ocean in this one, it's very dangerous for the fishing boat. Maybe for the ferry or cargo, the big ship. You can see the cargo ship safe to sail over the Indonesian sea, but they also have risk level in the low level in the Pacific Ocean. Okay, so we also have the prediction for each port in Indonesia. Okay, for the port, for example, in the Jakarta, maybe. Yep, in the Jakarta, we have a prediction in the port. The weather is cloudy. The wind is 4 until 10 knots from what is southeast, and the wave is calm. And this one is the general description of the weather information in this port. And we have also the local warning. This is the same. This is for the port. So this one for the map of wind speed, significant wave height, and others. And also, this is the important thing of Inawis. We have the fishing ground. So we develop this system together with Ministry of Fisheries. So we combine weather prediction, weather and ocean prediction with the fishing ground. So the fishermen can also see both of the weather and the fishing ground. For example, in this one, in the Makassar Straits, we can see there is a group of fish here, and also the wave height is not significant. So the fishermen can also go straight to this location to catch the fish. Yeah, but for example, in this area, in this western of Lampung, in the Indian Ocean, we can see the group of the fish, but the wave height is very high. It's about more than 4 meters. So it's very dangerous for the fishermen to go to this area. This one is for fishing ground. And also we have a cloud satellite from the Himawari. This is an infrared satellite. We can see maybe like this one. Where is it? Because in the Indonesian sea is not significant, but maybe like this. In the northern of Papua, the Pacific Ocean, we can see so many clouds. Maybe this one is a convective cloud like cumulonimbus or cumulus. So we can see in this area, probably it's happen heavy rain. This one for the satellite, and also we have the altimetry. This is for the wave height, and also we have sea current condition, but it's adjust to the risk level. It's same with the weather impact for the ships. So we have also marine or ocean HF radar. We have 4 HF radar in Indonesia, in the Sunda Strait, and also in the Bali Strait, Lombok Strait, and Labuan Bajo. We can click in this area, in this point, sorry. This one is current, surface current. It's near real time. Okay, this is for HF radar. And the last one, we have weather radar. So we have all of the information in the one website. So for the fishermen, or maybe for the pilot boat and others, they can just see our website to predict, to see the weather information, and also the fishing ground and others. Okay, maybe that's all for me. If you have any questions or you want to discuss about, with our BMKG OFS, you can type or ask to me. maybe that's all. Thank you, Mbak Cynthia.
Okay, thank you, Pak Rismanto. Okay, fellows, if you have any questions or want to discuss with us, let me know, and please don't be hesitate to ask. Or before, if you don't have it, or maybe if maybe it's we can go to the quiz before the question session, before the discussion session. So I would like to share about, you can open slido.com. Everyone can see this. It's only 3 questions actually, just short questions. So please, everyone can join. Okay, just click just click slido.com on your browser, Carter. Let me know if everyone already joined. Okay. Okay. Okay, there are some people already joined here. All right, we will wait you, Sabiha. Perfect, Jen. Okay, should we start now? All right, maybe we can start now. The first question, please. Oh, oh wait, everyone cannot see the question. All right. All right. Now, please answer the question. What does the term significant wave height refer to in marine meteorology and oceanography? The first one is the average height of all waves in a given area. Second one is the highest wave in a wave set. And the third one is the average height of the highest 1/3 of waves in a wave record. Oh, okay, maybe Carter needs the code. I will copy first. Okay. Maybe I will wait for Carter team to join to answer the question. Are you already on Slido, Carter? Please let me know. Okay, maybe we can go to the next question.
Yeah, Cynthia, you type number 6 and 5. It's should be changed 87824, then 65.
Oh, okay, I'm sorry.
You type 56. It's okay. It's, everyone, because me also cannot join to your slider.com. Now I can join.
Okay. Okay, Luis, can you try again with the new code that shared with, by Miss Ami? This is the code. Okay, go to the next question. If you see a marine weather report that states the wind has NE 15 knots, what does this mean? The first one is the wind is blowing from the northeast at 15 nautical miles per hour. Second one is the wind is blowing towards the northeast at 15 nautical miles per hour. And the third one is the wind is blowing at 15 knots in a circular direction. Oh, really? Okay, I will wait for the responses. All right, again, the last question. Wait, maybe. Okay. What is the primary unit of measurement for the ocean currents? First one is knots, and then the second one is miles per hour, and then the third one is meters per second. I think everyone already answered it, right? This is the easy questions. Okay, I will show the result. For this one, there is some people answer knots, meter per second. Actually, the answer is knots. This is the question number 3. Let us see for the previous questions. Oh, the answer is okay. most people answer, about 75% people here answer the wind is blowing from the northeast at 50 nautical miles per hour. And about 25% people here answer the wind is blowing toward the northeast at 15 nautical miles per hour. So the answer is A. Who is answer number B or number 2 or the second one? Oh, okay, cool. Okay, the first question. The result show. All right, what does the term significant wave height refer to in marine meteorology and oceanography? About 83% people here answer the average height of the highest 1/3 of waves in a wave record. Okay, still counting, about 14%. Oh, it's moving. About 25% now, the highest wave in a wave set. And then the third one, oh, it's still moving. Maybe some people here are still confused which one the answer. Okay, okay, for the most answer is the number A, or the average height of the highest 1/3 of wave in a wave record. These questions and the answer is already explained it by Pak Riris before. If you pay attention, or if you pay attention from the Pak Riris slides before, you can answer it very easily. Okay, the answer is B. Sorry, I think this is the answer should be A. I think I have mistaken. Sorry guys, the answer should be A. The average height of the highest 1/3 of waves in a wave record. I'm sorry, this is the technical mistake, the technical problem. So I'm so sorry. The number 1 question is the answer is A. The average height of the highest 1/3 of waves in a wave record. So let me know who's the one have three right answer. You can type on chat, and who's wrong with one question, or all your answer are wrong. How about you, Jane? I think you are the expert one here.
No, I'm not, because I get only one correct answer.
Oh, really? Okay, what about you, Prada? Let me know. Oh, okay, this is Dash. What about you, Prada? How many questions you got
I got
right
three.
answer?
I got three
Oh,
right answer.
perfect. Perfect. What about you, Hafiz? Or Carter and friends? Sabiha?
I got 2.
2, okay. Which one you were wrong?
I think
The
it's
last
2.
one, because I didn't get the chance to read it more. Because I want to join.
Okay, it's okay. I think everyone can. Okay, I'm sorry. So the quiz session already done, finished, and we will go back to the question and discussion session. that, like I mentioned before, that if you have any question, please don't hesitate to ask us. That Pak Riris, Pak Rismanto, and I will collaborate to answer your questions. Or if you have any recommendation to discuss, please let us know.
Hey, I have a question. Okay, like in the ocean, so there are no internets, like how fishermen, like in my country, most of the fishermen are uneducated. So, and also in the ocean, there are no internet, no network. So is there any way to get weather update, like in the ocean, so they can get prediction and probably message? Do you have any comment about this?
Okay, thank you, Hafiz, for the question. Maybe I'll try to give answer to you. The same condition, I think, in with Indonesia, because the most of the fishing boat has no satellite communication, because the only communication link that reliable in the middle of the sea is only satellite, right? So it is still a big problem also for many countries, I think, in terms of fishing boats facilities, communication facilities. So what we teach to our fishermen during our fisherman weather field school is to encourage the fishermen to access the prediction before they doing their activities. I mean, they do fishing activities at sea. So by understanding the weather condition, from our weather prediction up to 10 days, we hope that the fishermen can plan their activities, how long they will fishing at sea, and by paying attention to the forecast that already delivered by Indonesian meteorological services. So at least they have guidance to choose which part of the sea they would like to sail for fishing. And then this will help to reduce the potential impact of the bad weather during their activities. This is the simplest way that still practiced in Indonesia, is to encourage the fishermen to access the information before they go for fishing. That's why we place display information with a smart TV and etc. in the coastal community center, or in the ports and the fishing ports. We already placed some of these public display that give information in real time update. Whenever we update the prediction, it is directly the display that we place in their area is also will also update it. So that's the strategy that we deliver to them during our program. But for the bigger fishing boat, I think they have communication facilities based on satellite, so they can obtain by the standard communication means based on the sea transportation authorities by using NAVTEX and other means that already in the regulation of IMO, by getting the update of weather warning in the text format. We deliver the warning every day. Every time we find that there is a potential significant weather in the sea, so we deliver this information to the port authorities, and the port authorities will deliver the warning messages through their standard communication protocol that they have for sea transportation. I think like this is I hope that it can answer your question, Hafiz, or maybe Pak Risman.
Yeah, thank you for your elaborative discussion. I like it. Yeah, I think the 10 days is enough.
Okay, what is the practice in your country, Hafiz? I mean,
Usually,
US I think is very advanced for the marine meteorology information. How about Bangladesh? As far as you know.
yeah, I have been in Bangladesh, like in fisheries sectors, few years. So I've seen most of the people, they don't know about predictions, but they usually assume that their sailing would be good based on the wind flow and the probably the sky, and believe in God. This is how they understand weather. We don't have any prediction system yet.
Okay. So yeah, maybe if the Bangladesh Meteorological Service has not provide the ocean weather forecast, maybe you can suggest the user or related stakeholder there to access the neighboring countries that provide. Maybe India. I think India is.
Yes, yeah,
advanced
India has
in
an
this.
advanced prediction system.
Yep.
Yeah, I think some of the commercials, fishing vessels, they use the foreign the prediction, but they have also advanced instrument.
Yep.
And I saw that some fishermen, they use GPS as well, but GPS uses is not a quite popular in our country. So it's like without an instrument, they go the sail vessel and fish for like 10 to 12 days, sometime in 7 days. Yeah, I'm glad most of the country have some system.
Okay, thank you so much, Hafiz.
You are welcome.
There
Hello.
another question? Sin?
Hello.
Okay, Sabiha, please. We can
My-
hear you if
I
unmuted.
don't, it's not such a question, but I want to see the product of the radar that can be used in marine forecasts. Radar products.
For me,
You mean
Ismata can
the
share again.
high frequency rate? Because we, as explained by Pak Rismanto in the simulation session, we already integrated two types of radar data in our information system for marine weather services. They are the weather radar and also the high frequency radar, or we can some people mention the HF radar is coastal radar or marine coastal radar. So these two type of radar is different. For weather radar that we integrated in our system is to observe the weather condition. As the simplest thing is the radar, the weather radar is detecting the area of where is the rain potential occurred. So if we see the radar image, weather radar image, maybe Cynthia can share the wish like to give a idea for Sabiha. So if weather radar coverage is up to the ocean region, some of our radar weather radar have coverage up to at least some nautical miles from the coastal area, so that the radar weather radar images can also add some information in the area where the ocean area is probably rainy or rainfall occurred in the area. But for this HF radar or a coastal radar, it gives information to us regarding the ocean surface ocean current. So the current condition in the surface level of this area that observed by HF radar can be seen here. So by combining the two, I think the user can have information or idea of the area of their interest about the condition of the current surface ocean current through the HF radar like this, and then the weather condition from the weather radar. Does it answer your question, Sabiha?
Yes, you answer my question, but I have more question. So this one for marine radar is different from that other radar.
Yes, this is different. The difference between marine radar and weather radar is the frequency that used for their sensors. So basically, weather radar utilized the frequency ranging from 2 gigahertz to 9 gigahertz. It's the most common of weather radar use this range of frequency. But for HF radar, high frequency radar, they use around 5 megahertz, not gigahertz, megahertz. 5 to 25 to 26 megahertz range of frequency. So it's depend on the object that they would detect. So if the target in the surface water, like the movement of water, it can be detected by radar with the frequency ranging from 5 to 26 megahertz. But for atmospheric target like rain, droplets or ice in the atmosphere, it can be detected. They can be detected by weather radar with the frequency of their transmitter of the radar ranging from 2 gigahertz to 9 gigahertz.
Okay. Thank you very much. So if there are any you can do any connection to, I mean, weather radar to do the same thing, to do two things.
What do you mean one radar?
I mean, if you have one radar, only weather radar, can you maybe organize or increase something in order to do the marine forecast also? Or you should have to get another radar?
Yeah, it's depend on the area of target that you monitor. If your country is only small, has only small area, that can be covered by only single weather radar, because the range of each type of weather radar is different. Usually we have 3 types of weather radars that has different coverage. The biggest coverage that can be achieved by weather radar that provided in the market right now is about 400 kilometers away from the radar site. It is the widest area of coverage. The second one, but it is very expensive because S-band, we call it S-band radar that has the widest coverage. It's very expensive because it's very big weather radar. But for the middle class of weather radar, we call it C-band weather radar. It has coverage ranging from 150 to 200 kilometers. This type of radar we operate in Indonesia. Almost all of our radar has include in this type. So if we place one C-band radar near the coastal area, we can expect that the coverage up to 150 kilometers toward the sea, we can obtain the weather condition there. But if the radar is placed inside inland, far from the ocean, more than 150 or up to 200 kilometers, we cannot obtain the weather condition if the radar placed away at the distance of more than 200 kilometers. You should put the S-band type to get this sea area to be covered by the radar. But for this HF radar to monitor the current condition, we operate 2 types of HF radar. One, we have around 16 megahertz, and the other side we operate the 25 megahertz HF radar. The coverage of this HF radar is a little bit different. The lower frequency of this HF radar has a wider coverage of sea current observation, but for the higher frequency of the HF radar or coastal radar, they also they have less coverage than the lower frequency of radar. So the distance that we can detect by using HF radar is around 50 to 70 kilometers from the radar site. So it is very, very small comparing to weather radar that has coverage up to 150 to 200 kilometers for C-band, and then for S-band we can obtain the up to 500 kilometers radius of observation. So if your area of interest is bigger than the coverage of one specific radar, so you have to put more than one radar to get the mosaic to complete the coverage of each weather radar.
Okay. Thank you.
You're welcome, Sabiha.
Okay, for another person. Maybe if you have any questions again.
So maybe if no question anymore, I would like to hear from maybe I would like to hear the sharing information from our colleagues. I have heard from Hafiz. And what about Philippines, Miss Jane? Can you share information with us how your meteorological services, national meteorological services, provide meteorological information for sea activities? Hello, Jane.
Hello, good morning, everyone.
Okay, hello, Jane.
Um,
Can you share
so,
with us?
here in Philippines, so I'm not so familiar with the applications that we're using for our meteorological system, but what I am familiar with is the informations that we're getting from this weather information system that is provided to us. So at sea there are especially for fishing vessel when they do fishing on sea, they are required some gadgets for communication, especially on the update of the significant weather that might affect the fishing activity as well. And inland, we have many information system, automatic information system. Like for example, we are receiving automatic alarm system if there are severe weather conditions happening in an area. So we are automatically sent with warning signals, alarm system, and our mobile phones.
Okay, thank you so much. So, but I believe that Philippines Pagasa provide also marine weather information, but perhaps the real-time update in the when the significant weather
Yes, sir.
event happen.
Yes, I think every 4 to 5 hours. I'm not so sure, but within 24 hours, they are giving us update about the weather system.
Mhm.
So there are websites of the Pag-asa that we can visit to if we wanted to want an information about the weather conditions here in the Philippines.
Okay. Yes. Thank you so much, Chin, for your information sharing. Is everybody any other else that would like to share or asking some question to us? How about PNG? Carter. How is the marine meteorology services in PNG, National Weather? Can you share to us? Or maybe Sabiha, you open mic, please.
For me, in our site, we did the forecast for fisheries, but we not include the in our products. We included the wind speed, wind direction, significant wave height, only 3 parameters. And weather, and weather, if there's any weather, maybe rainfall or thunder shower, like that, any activity.
Okay.
So for me, I need the products that can be used to get the forecast of salinity and the soil in our sites.
Okay. So by the way, where are you from? Are you from
Tanzania.
Oh, Tanzania. Okay. Tropical Africa, yeah.
Yeah.
Yep. I think you have also ocean region. So we encourage you to propose to your meteorological agency to also develop this kind of products, because it's very
Mhm.
important, not only weather condition in land, but also in sea, because Tanzania has also sea area.
Yeah, we focused in the sea, but we did not include the salinity
Okay.
and soil.
Okay.
Only two parameters in our products of that are given to the fisheries, not include salinity and soil. So for my side, if I get this product that can give the focus of salinity and soil, maybe it will help us either to include also the soil in our products and also salinity.
Okay. So Tanzania Med Service has operate the marine model forecast or not?
Yeah, we do.
Okay. So maybe you maybe Pak Rismanto can provide Sabiha with information regarding the
Salinity
model,
and the soil.
model that can produce the salinity and soil model output prediction.
Okay, Paris and Sabia, I will check the availability of other models, other global models such as HMWF, because the HMWF or it's a consortium of weather and ocean
Oh yeah, Copernicus,
institution, the Europe,
Copernicus,
yeah, Copernicus. So I will check if they have the products like salinity and also soil.
Okay, thank you. And then you will share to me.
Thank you so much, Sabia.
Welcome.
Yes, you can check out the Copernicus website also. I believe that many parameters that already provided by European Consortium for Meteorology and Oceanography. I think they also provide for African countries. So I suggest you in African region to explore the Copernicus website for the weather and marine products there. And you can communicate also, I think, with the experts of European Meteorological and Oceanography Consortium there. Okay, Cynthia, I think the time is up, so I will hand it over to you and Mbak Ami to continue. Thank you so much. And hopefully the sharing knowledge from BMKG Center for Marine Meteorology can benefit for us and for all of you, and looking forward to communicate in the future with your colleague of the Med Service or other colleagues in stakeholders of marine stakeholder. Thank you so much and have a nice
Hello.
day.
Sorry. More question, please.
Yeah, please, Sabiha, last.
Yeah. My question is not a question. You see, this program is too interested for us. We get sharing knowledge, information, knowing each other, but depends upon different time according to the location. It is very, very, very difficult to get all of the things in this program. So, is there any maybe any program in sight after this in order to build what we will have learned on site program?
I will hand it to Ami to answer this. Is there any continual program after this, or follow up program?
No follow-up, yeah.
Yeah, Sabiha, maybe just because we already have the group on WhatsApp group, I will send you the information on WhatsApp group. So keep in touch with us.
Thank you, Ami.
You're welcome.
Okay, we get answer from Carter regarding my question because his mic is not working well. So yes, PNG Met Service provide the ocean water forecast of synoptic situation and warning. What else? What about the wave prediction? Do you include also in your product?
Mpaka mafuta vibaya, sipendi. Uso hauna mafuta chochote.
Okay, thank you, Carter. So the wave height is also included in the forecast of PNG Met Service. So I have several colleagues of PNG who ever visit BMKG also and give our regards to our PNG Med Service colleague, Carter. Thank you. Thank you so much, Carter. I hand it over to Ami and Cynthia. Thank you.
Okay, thank you, Pak Riris. Maybe just direct to Bu Ami to finish this session.
Yeah, okay, thank you, Cynthia. Mr. Iris, also Miss Ulfa, Miss Slamet, Mr. Slamet, and also Mr. Rismanto. To all participants, thank you for joining us to this synchronous. I reminding you, before that, I want to ask, you can open your mic or you can type. Did you already access the LMS, Otga's LMS? Carter, Sabiha, Luis Pedro, Gabriel, Matthew, Jane, David, Juan, Lucien Benso, because you asked me the lesson, the activities, but I just want to ask, yes, okay. Yes, David, Jane, thank you. How about the others? Yes, okay, Gabriel. The others? Because a few participants already do the pretest. If one of you didn't do the pretest, so please do the pretest because that's our activities to get the certificate. Okay, Joan, Sabiha. Oh, okay, okay. Who else besides Sabiha? Joan Pablo, it's okay. Lucien Benso, did you already access the Otgas LMS? Because we have a synchronization also in Otgas LMS. That's the point of get the material also. Okay, I assume you not yet Lucien also. Okay, Sabiha and Lucien. Okay, I will send you and I will assist you how to get to the Otgas LMS on group. Okay, so thank you for this morning. The session is very amazing, incredible. Yeah. See you on next synchronous on Thursday. Thank you, Mr. Iris, Miss Morfa, Miss
Thank you, Ami.
Cynthia, Mrs. Slamet. Yeah, Miss
Thank you
Rismanto.
all participants.
Yeah, participant. Thank you all.
Thank you.
See you on the next. Yeah.
See you.